Okay, so this is the final video that we have to do about circles, I believe. I think this will wrap it up. And again, let me tell you where we are. We're doing 2.2 in the book. It has to do with homework number 7. Let's go to my usual. And here we go with the pencil. And what are we talking about? We are talking about we had first talked about the first thing we were talked about was the standard form of an equation of a circle, and then this what we're talking about right now, number 2, we're talking about the general form. All of that was in a previous video, and I think if we can call it a continuation of our previous video, I think we're up to problem number 3. And we went off on those tangents about how to complete the square, but you'll see how we're going to use it now. Let's say you have a problem that says like this: x squared plus y squared plus 10x plus 10x minus 6y plus 25 equals 0. So that's in general form. That's in general form right here. But the question is, they ask you to put this equation in standard form. Convert this. Here's the question. I'll write it over here. The question is convert this into standard form. That's our goal. Convert it into standard form. Okay, here's what you got to do. Take the x squared and then skip over the y squared. Put the plus 10x over here. Plus 10x. Okay, we've taken care of those two. Skip a space, right? Just ignore that space. Now put the y squared, plus y squared, which comes from this. Then put the minus 6y. Okay. And then get the negative 25 on the plus 25, get it on the other side. So I'm going to not write plus 25 equals 0, minus 25 on both sides. If I do minus 25 on both sides, I get minus 25 over here. This will be gone, and I get minus 25. That's our setup. Okay, now I need a little space. Well, I'll need that little space over here, but I can squeeze it in. Okay, now I go for scrap paper, and here's what I got to do. What I need to do is I need to complete this square. Here's an x squared. Here's a 10x. How do I make this into a perfect square trinomial? I go to scrap paper. I take that 10. We've practiced this already in the previous video. Divided by 2. 10 divided by 2 and square it. That would be 5 squared. 10 divided by 2 is 5. Squared is equal to 25. And there's the missing piece that I want, plus 25. Go over here. And how do I make this into a perfect square? I got my y squared. I got my minus 6y. I go to my scrap paper. I take minus 6 divided by 2 and square it. That would be minus 3 squared is equal to 9. So I put a plus 9 over here. I got both of them in as perfect squares. Now if I add plus 25 over here and plus 9 over here on one side of the equation, the only way that that's legitimate is I add plus 25 and plus 9 over here. That's the only way I'm allowed to add plus 25 and plus 9 if I do it on both sides of the equation. Okay, what does that get us? You're going to see where we're going to go with this. How I have to factor this perfect square trinomial, but it's easy. Take the square root of x, take the square root of 25, plus 5, and that's it, because x times 5 is 5x, times 2 is 10x. If you make a perfect square trinomial by completing the square, you know for sure that this is all you got to do. This is the factors. Now what about this? I take the square of y squared, which is y, takes the square root of 9, which is plus 3, positive 3. I'm sorry, which is, since it's negative over here, it's a negative 3, and square it, equals minus 25 plus 25, they cancel each other out, equals 9. And now I have it in standard form. We have successfully gone from general form into standard form. We converted it into standard form. Right over here. Now, from there, what is the center? What are the coordinates of the center? We did this before. Take the opposite of plus 5, which is negative 5. Opposite of negative 3, which is positive 3. There's the coordinates of the center. What is the radius? The radius, well, the radius squared is equal to 9. Take the square root of both sides, and the radius is equal to 3. So I'm able to get the center and the radius once I put it into standard form. And what was the question? We went from general form into standard form. Okay, so that completes our story about equations of circles.